Hi, today I want to talk about integration by substitution, and I will show this technique by solving two examples here. So let's take a look at the first integral. So we have x in both numerator and denominator. So first of all, let's make the denominator into the square of sum, so that we collapse this into x squared plus 1 and then take the square. And then in order to make the denominator complete, we also plus 1 to make this equal to this. And here you can see that since we have two squares here, so we set u equal to x squared plus 1. So basically it's the things that is in the parenthesis. So this is what we call by substitution. So we substitute something into this formula here. So basically so if u equal to x squared plus 1, then du is equal to the 2x dx. So basically just taking the derivative of this here. So basically just 2x. So now let's rewrite this integral here. So basically just u squared plus 1, that's the denominator. And then x dx is basically just 1/2 of the du. So we put 1/2 here. And then we can drag 1/2 out to the outside. And then we are basically evaluating 1 over u squared plus 1. So basically this is something you need to memorize it. So if you see u squared plus 1, basically that is just arc tangent. So basically arctangent is inverse of the of tangent. So basically just getting is so basically for tangent it's just like you input a degree in this kind of function, and then it will return a number. But however, here you are just we are taking the inverse of a tangent. So basically, we are inputting a number to arctangent, and then it will split out. It will output an angle of a triangle. So this will basically output a theta, something like that. So this is a formula you need to memorize. So 1 over u squared plus 1 is basically arctangent. And then so after so actually in this step you already have your answer to the integral. But however, since we use the substitution, so we need to bring back. So we have a function. We have the answer of this integral in with u as a variable. However, the original function has variable in terms of x. So we need to bring back the x into our solution. So basically we just bring u back to here. So basically just 1/2 of the arctangent of the x squared plus 1, while we set u equal to that, and then plus a constant. So basically by using this substitution, we are able to solve a complicated integral in two steps. So first, let's substitute part of the original function, and when we get the solution, we bring the substitution back to our original function, and this will be your solution to your integral, and also in terms of variable x, not u here. So that's our first example. So now let's take a look at the second example here. So we have we're evaluating the integral of x sine x squared. So first of all, let's think about how we can when we see a square of a sine or cosine or tangent, we always make them to a lower degree. So basically, let's think about any. We need to think about any formulas that. Well, we should memorize some of the formula to have a better solution for the calculation. So let's think of some formulas that we memorize that involve sine x squared. So we have something like this. So cosine 2 theta is 1 minus 2 multiplied by sine theta square. So you can either memorize this or memorize some other function that can help you to that will lead you to something like that. So you can also memorize cosine 2 theta as cosine of theta plus theta. So basically that is just cosine theta multiplied by cosine theta minus sine theta multiplied by sine theta. And then you have basically just cosine theta square minus sine theta square. And then cosine theta square is actually also 1 minus sine theta square. So that you have 1 minus 2 of the 2 times sine theta square. So this is just multiple ways to help you to memorize the formula. But the best way for you to evaluate or to improve the speed to solving an integral is to memorize all the formula. There's nothing to negotiate. You have to memorize these. So in order to solve the integral. So now we have so now we want to rewrite sine x square. So basically we use this formula, and then sine x square is basically the 1/2 of 1 minus cosine 2 theta. So we put this. So we use this part to substitute sine x square, and then we bring the. And then now we have this as our new integral in terms of theta, not in terms of x. So now we have so now in this cosine function here we have a 2 theta here. So we set u equal to 2 theta. So that du is just 2d theta. So now let's rewrite the function here. So we have 1 minus cosine u, and since d theta is just 1/2 of du, so we put 1/2 du over at the end, and now we drag this 1/2 outside, so we have 1/4 of the integral of 1 minus cosine u. And now this is just a simpler integral. So basically that is just u minus sine of u plus a constant. So remember, we have a function here. This is our solution to our integral, but in terms of u. So now we need to substitute back to make the solution back to our original variables. So now we bring back u equal to 2 theta. So now we just have 1/2 theta minus 1/4 of the sine 2 theta plus the constant. So these are two examples of using substitution to solve integral. So basically, when you see some complex integral, look into the formula, or look into your function here and see if there's anything you can substitute to make it like to make it simpler. While after you solve your integral and then substitute your variables back into your function, and then rewrite your solution into the variables that it is originally in your question. So this is integral by substitution. So thank you very much, and let me know if you have any question.